Good morning, sir.
Morning.
Yeah. So we'll start in few minutes.
Sure.
Good morning, all. Welcome back to day 2 of the AICT-sponsored 6 days virtual short-term training program on robotics, artificial intelligence, and control. Today, we have Dr. Prahlad Vadakepat sir with us to handle the first session. Dr. Prahlad Vadakepat, an associate professor at the National University of Singapore, is the founder secretary of the Federation of International Robot Saucer Association and currently its general secretary. He is one of the resource persons in the Igniting Minds movement by Vijayana Bharati India, which is a program enabling students to shed conventions and think out of the box. He is the founding editor-in-chief for the Springer Journal of Frugal Innovation, which is an open access journal aimed at creating a platform for ideas and innovations for an inclusive growth. He has initiated an international conference on frugal innovation, which was planned in Singapore in 2014. He runs the Ideas for Life Social Entrepreneurship Challenge, seeking design innovations which are simple and novel, and directs the frugal innovation effort of NUS. He was the general chair to the FIRA Robot World Cup and Congress Bangalore 2010. He was the founder director to an entrepreneurial startup, Robata Robotic Solutions at Singapore and Bangalore. Dr. Vadekepad is the editor-in-chief for the Springer Handbook of the Humanoid Robotics. He's an associate editor of the International Journal of Humanoid Robotics. His humanoid robots and robot saucer teams have consistently won several international prizes. He is a member of the CIA National Committee on Robotics, Confederation of Indian Industry since 2009. He's a senior member of IEEE USA since 2005. He was elected as the secretary to the IEEE Singapore section for the year 2005. He has served as technical activity coordinator to the IEEE Region 10 Asia Pacific in 2001-2002. He's also a fellow of the Institute of Electronics and Telecommunication Engineers, India and FIRA. He has been featured in several prominent newspapers and TV shows in India, Singapore, USA, Korea, Japan, Spain, Kuwait, Dubai, Qatar, Bahrain, France, and China. Professor Vadekepad received his MTech and PhD from IIT Madras in 1989 and 1996 respectively. While pursuing postdoctoral studies at the Korea Advanced Institute of Science and Technology, he was awarded the Korea Science and Engineering Foundation Fellowship. Since 1999, he is with the National University of Singapore. His research interests include frugal innovation, distributed robotic systems, humanoid robotics, biomorphs, neurofuzzy controllers, and intelligent control techniques, and has publications in several leading international journals. Sir would be handling session on the topic humanoid robots today. We welcome you, sir, to the session. Sir, could you please unmute yourself?
Yeah, today we have 1.5 hours. Am I right on that?
Yes, sir. Yes, sir. Yes, sir.
So can you see my screen?
Yes, sir. It is visible.
Okay, thank you very much. So nice to be here, and take care and manage yourself under these difficult times. So I've been working in robotics for a long time, and I went to South Korea. I was in NIT Calicut, REC Calicut then till 96, and got a postdoctoral fellowship in Korea Advanced Institute of Science and Technology. That's the time actually, I was able to touch the robot for the first time, because in India it is more theory-based, and even during my post-graduation at Madras, the fundings were limited and couldn't do much, though I learned theory about manipulators in IIT Madras. And to tell you, frankly, I was scared. My professor asked me, if you want to contribute seriously, you have to get your hand dirty. And he gave me a very small robot that I have to assemble from scratch. And I looked down on myself to start with. And I realized that I can do it. That's the biggest learning in my life. There's nothing difficult if you don't scare yourself away, and also do not think that it is not doable. Okay, and don't get scared about doing. And I did it, and did the PCB, including the, because it is one of the smallest robots, so there was no PCB per se, so I had to use a common board and put all the resistors, capacitors, and active devices, and I had to solder it, and I had to do all the connections, and do some mechanical cutting and shaping. And I was surprised that when I turned on, it worked. And that was the confidence I got from there. And there was no ending. And I'm proud to worked with a number of people in Korea, and later I got very good students from China, India, Singapore, Europe, and Malaysia and other countries nearby. So whatever I'm sharing is because of them, and I respect their contributions and making me to share with you. So that is the background I would like to share. So I started with fuzzy logic and artificial neural networks long back, as early as 1987 in Madras. Maybe I was one of the first persons to start on fuzzy logic. So why I'm saying all this is that never delay learning. And I think you are all staff. And I suggest you to really keep the lecturer, assistant professor, associate professor, and professorship, head of the department, all those things outside, okay? Throw it away. It's no use to us for learning, okay? So you should try to, make your hands dirty. I mean, it is a way of saying, and learn new things. And humanoid robot is a very hot topic. Unfortunately, in India, except BITS Pilani and some student-led initiatives, many are not really working. Okay, there's no real big research there. Okay, so I will give a very brief background, and then we go to the humanoid robot. So industrial robots are, designed looking at our arms, and it is established, beaten, and making our lives easier, better, and we have the very costly mobile phone being delivered at the cost that is affordable to the common man. It's because of the reputation, scalability, and sustainability of the product development as well as manufacturing. So we are very good at that. Mobile robots came into existence lately, and now it is accelerated because of various kinds of sensors, very good computing powers, and with 5G that is on the anvil, it will take off like anything, because connectivity is the issue. I just finished today morning a PhD defense by one of my examiner, where this particular student, she is a scholar, developed an amphibious vehicle which can fly, and it can also enter into water, and it can reconfigure. So the morphology can be, changed. And we made a comment that someone made, one of the other examiners made a comment that sky is the limit, and I said sky is not the limit, that is gone. And then another examiner made a comment that all those are not the limits, the communication is the limitation, that is the limit. The communication is the limit now, but it is going to change. So with 5G and all that and other developments, the limits will vanish. And that's the world we are in. And anytime, please do, have any questions to ask, do unmute yourself. Don't respect me by keeping silent, okay? And I can't see the chat window because of this, so please do unmute and speak, okay? Feel free, okay? All right, so industrial robots are superb, very good, and a lot of work. But I would like to say there are some developments in this space where, collaborative robots are coming up in a big way, wherein humans and industrial robots can work together in the same space, and they can share space and time, which is not possible with the traditional industrial robot. So that is another area where a lot of work is going on. Now, with respect to mobile robots, so humanoid is a mobile robot. You can see there are plethora of applications, okay, wherein quite a lot of things are happening. And then when a robot is moving about, there are quite a number of questions to ask. The three key questions are, where am I? The robot should know where it is. And this is not a simple question. Of course, the robot has a prior map of the environment, whether indoor or outdoor. You need to know your coordinates to relate to the map. And there's a very interesting problem, research problem. It's called robot kidnapping problem. Just like humans are blindfolded and put in a sack bag or whatever it is, put in a vehicle, you go around and you release that individual somewhere, how he or she will know where he or she is. Similarly, if you really lift the robot and carry it around and put it in another place, will it be able to know I am in a new place or I am in a different place? So this is not a simple problem. And also need to know, second issue is, where am I going and how do I get there? These are very important questions. So you need to have a model of the environment, perceive and analyze the environment. You need to know the position in the environment, and then how do you go about moving from point A to B or point A to Z through all the via points? And that's a very hot topic. Currently, my PhD scholar is working on that, and he's working on a any angle algorithm. So in omnidirectional, any angle, optimal, and there are quite a lot of issues when it comes to indoor navigation for mobile robots. So it's a very interesting work and theoretical work, as well as finally we'll be implementing on it. And so specific to mobile robots, the locomotion is important, and how do you navigate? So perception, knowing its position, planning, and motion generation are very crucial. So the general control scheme can be considered as, you have two sides of it, the perception side and the motion control, and then robot works in the real environment. So you have to have an environmental model, and the perception will perceive sense and able to extract information, features, or landmarks, or whatever it is, based on indoor or outdoor, and then localization. And you can, if you don't have a map, you can build it, and then you will know the position, and then mission, based on the mission commands, you have to plan the path, execute it, and the commands are sent to the actuators, and this process continues. So we do it. Any living organism is capable of doing this, and even from the microbes to the human beings. Okay? And of course, there are very interesting ways to represent and model environment. So one interesting things we do when we are kids, treasure hunt, odometry, you walk around and find around things, right? Yeah. And also, like in a airport, you can have modified environments. But it was expensive, but not flexible. But eventually, we cannot consider robots independent of the environment. So our learnings are dependent on the environment. So my personal view, and I articulate that, there is no independent intelligence for the robot, and intelligence is part and parcel of environment, dependent on the environment, as well as the robot capabilities. So we have to see it in a symbiotic manner or a holistic manner. And of course, we are very good at, feature-based navigation, how to look for specific features. So that is another area which we are not going to touch upon. Today, I'll touch upon some feature extraction related stuff. Okay. So localization, of course, there's a flight going above my head, okay? Sorry for the noise. So here is an encoder. That is one way to know wheel encoders can be used, odometry, and you can see with respect to the map where you are, and then through the perception you can update it, and you can also have probabilistic map based localization. I'm not going to those spaces right now, but there are challenges. Absolute precision is not always easy to get, and even if you know that, it's not sufficient, because in relation with the environment, how do you go about localize? Okay, and so that is the most crucial part. And to be frank with you, we all have GPS in our head, okay? And for me, I'm a unique guy. I'm not at all good in using a map. I can't get directions. So I cannot understand north, south, west, east. So if a map is given and you give me that, I'm lost. So that is extreme one condition of human being, okay? So but some people are extremely damn good, and they can relate to any direction very easily. So you need to have algorithms to localize, and there are a lot of interesting things, especially from the point of view of autonomous vehicles. It's just coming up in a big way. So perception is very important. So we are not going to that space. And the state of the art is the real world is dynamic. Perception is still a major challenge, and quite a lot of issues, and so much of open space. And how do you go about boundaries in a topological manner with nodes? And also people are working on multiple different kinds of sensors and sensor fusion that is helping. But still there are blind spots, and there are a lot of issues, and we will keep innovating and researching and developing. And of course, other ways of localization, if you can really modify the environment, you can have beacons to really put the localization possible. So my first company, which introduced the floor cleaning robot in Bangalore in 2009, we had the beacons to virtual walls, etc. I could not continue with that because India was not ready to accept floor cleaners at that time. Now it is becoming better. So we were too early sometimes. And of course, other ways we have done some work using even Wi-Fi, but not very accurate. And but triangulation is the way in GPS and everywhere. Okay, so that's the area. So typically in a mobile robot, and whether it is humanoid or other, you have to have localization. And one of the very interesting area is simultaneous localization and mapping, SLAM. And there are visual SLAMs, there are depth-related LiDAR-based, and even the other university in Singapore, my colleague has developed a LiDAR which can be distributed through fiber optic cables. So the LiDAR can be inside, hidden somewhere in an autonomous car, but distributed fiber optic cables can be ending at the four sides of a vehicle and be able to get a 360 view. Okay, because the LiDARs are very costly and we cannot have a number of them. So there are a lot of interesting works like that. So I'm not going to talk about SLAM. So sensors, I put a slide here. It is too small, but in font size, but there are a lot of them. So typically, we have to precision. We need to know where we are. Okay, so control, automation, and robotics are very hot in any industry, and when we are preparing our engineers, we need to position ourselves in such a way that the value of even the components, subsystems and systems and large-scale systems, how that will function in the industry to be shared. Okay? And coming to robotics specifically, there are various developments. Home domestic robots, hospital logistics is very hot. Mining and exploration, a lot of things are happening. and disaster response robots are becoming very hot. Undersea exploration. Now India is going into send robots to the depth of the ocean. So if you go to National Institute of Ocean Technology, so my senior was a director, he retired 2 months back. They have done very good work, and they have collected billions of years of old ingots from the seabed, and there are a lot of rare metals available. And in the industrial space, collaborative robots are becoming very hot, where you can share and this time and space with humans. So that is the background, and I would like to now go into the humanoid robot. And you all know the Honda Simo is one of its kind, multiple decades of research and development, billions of dollars. It is to show that the capability of the company, and they have done a wonderful job. So we may take it for granted walking is extremely difficult. Okay? And here there are several aspects: the power and energy, microelectronics in terms of communications and networking, control, intelligence, and robotic aspects. Of course, sensors and other algorithms are also there. So energy source is very important, and how long it will last. So that's the beauty of human being, we can last for 70, 80, 90 years. And a little bit of water can help us to move about. Our energy generation system is so good. But here, if you look at it, 20 plus or 30 motors and how much power is required, that is a bottleneck. But with developments in very interesting battery technologies, wireless charging, things are changing. So it's a chicken and egg issue. If you have a bigger robot, you have a bigger battery to carry. Bigger battery will increase the total weight, and you need a bigger motor to manage it. So it's a chicken and egg issue. So we have to really strike a balance, okay? And of course, the other, sensing, tactile, vision, and other aspects are very hot, and also need to know the contextual information. So when you're walking, and if human being is walking towards you, there is occlusion, or there will be multiple people, and someone is trying to communicate or through certain gestures to the humanoid, how the humanoid be able to understand that that individual is talking to me. Okay, so we have done some work on attention-based hand gesture recognition. Okay, against complex background. I'll share that later. So the most important part as far as humanoid two-legged motion is concerned. Now, humanoid is generally considered with 2 legs, okay? But there are robots with 2 arms, but a moving, wheel system. That's not actually a humanoid, but can be a humanoid. The most important thing with respect to two-legged system is the stability. And typically, we have to keep the center of gravity under the foothold, and we are good at that. So you can stand on one leg, and if you have to stand on one leg or do Kuchipudi or Bharatanatyam, basically we know how to really position ourselves in such a way, the posture is made in such a way that the CG is within the foothold. And when we are walking, see an elderly person walking, the person cannot walk fast. So he or she will shift the CG from left to the right, and to the left, and to the right. That's why that swinging is there. And the upper body is very important. That's a mass stabilizing it. So if you look at a circus person walking on a rope, and then that individual will be carrying a long rope, and that is a counterbalance. And so being a long road, the momentum that it can have in terms of a slight motion is sufficient to balance the forces, otherwise will be very strong on the body and the body will be made to fall. So you need to really be very careful about the central gravity thing, and zero moment point is a terminology used. So that is the point where there is no reaction from the ground, or it's something like if you are about to fall off, if you have a stick, what is the point where you put the stick so that you will not fall? And when you are in an unstable position, the CG really falls out, and there is a point where if you really have a third foot, or you shift one of your foot to that point, you will not fall. Okay, so these are all the very interesting work. A lot of work has been done, and we have done some work as well. And also, the situation becomes more complex when you have rotation. So there are sagittal planes, and therefore, X, Y, Z, so forward and in the horizontal and vertical planes. And if you have to have three-dimensional walking, there will be turning momentums, and depending upon the mass, depending upon the forces acting, depending on the reaction forces from the ground, or somebody is pushing the robot, how it will behave. So these are all have to be studied. So we started this in 2001, and this is the first humanoid. I mean, not the first one. I mean, there were other designs. So it was 2.5 kilograms, and don't be carried away by the sensors and processors, because it's about almost 2 decades old, and lately we have modified a lot. So be careful about that. Okay, and we had digital signal process. So digital signal processing was done at that time. Robot operating system was not there, and camera had a pan, tilter, and tilt. And then we have 4 sensors at the foot to know whether the foot is put properly on the ground. And I have some demonstrations to show how that is made use of. Of course, we had infrared sensors. Of course, this is old sensors, and there are better ones. Digital compass, again, better ones. And CMOS camera from CMU, we use RGB and YUV for object tracking. And so it will be able to track a ball and play the game of soccer or football. Okay, so that was done. And flexi, 4 sensors were kept at the bottom to know whether the foot is being precision and pressed in a proper manner, or there is a tilt towards one direction or other, and accordingly you have to compensate the the signals to the 2 legs and the motors in the legs. Okay, and for that we also have a tilt sensor to know, especially for the roll and pitching up. Okay, so rolling and pitching up. Yeah, so 2 analog outputs were there at that time. So that's how that was positioned. CMU camera there, head tilt motor at that particular point, head pan motor at that particular point. And then to know the orientation, we use a very interesting concept. This is done by one of the final year project students. An infrared sensor was placed, and it can rotate about 180 degrees, so that you will be able to know, because you didn't want to have too many sensors. So you can have a single sensor and you make it rotate, and that will act like a multiple sensor system. Only thing is the data that you get from this, the same sensor will be delayed by seconds. Okay, that is still okay. So you can have a 3-dimensional depth information using a single camera, and you can move the camera instead of having 2 physical fixed cameras taken simultaneously. And if you assume the scene is not changing very fast, you can have a camera here and move it to the one side, and within a time gap of milliseconds or seconds, and then you can take another still picture, and that can help. So, and even with one of our eyes closed, we are capable of doing that. We move your head and then see, okay, I can see the depth information. We can get that. Of course, digital compass, there are better ones here these days, okay, infrared sensors, okay. And so I'd like to show how the force sensors were incorporated. So this is the scenario, say, where a wooden surface, and it will go into a metallic surface and see the reaction, okay. And then it was compensated. It takes time to stabilize, so the control is effective, and then it is back onto a wooden surface. But now the left leg is on one plank, the right leg is on the another plank, and there is a vertical movement as well, and also slope, and then varying slopes we try to. So the compensation algorithm was quite working well. Okay, yeah. So of course we need to have the mathematical equations, block diagram. I'm not going into that depth at this moment. Okay, you can go through some of our papers on that. And the balancing we have done in a very nice manner. And basically, if say one of the legs, the platform is lifted up, and there is a change in the height, okay, where the foot will be, and how do you make sure that the hip is at the same level, horizontal level? So you have to change the control signals to that leg, and bend the knee so that you'll be able to do it. So you can do this very simple, that you can, this tilting or this change can be sensed at the hip level. It can not be perfectly accurate, but it's fine, okay. And then you can send signals in such a way that the hip is kept in a horizontal manner, okay. So you can have a feedback system there to make sure the hip is at a horizontal manner, so that the tilt sensors will not be giving signals that it is tilted. And balancing, of course, there are different ways of doing it. So one of the methods is that you bend the knee. Now, can we follow, if we observe ourselves, how much we bend our hip joint at the hip joint, how much we will bend at our ankle joint, okay? So what we did was we tried to make these two angles at the hip as well as ankle the same, equal to same. So theta 2, theta 2, and then you can have the theta 3 for the knee. Now, of course, you can do simple trigonometric equations, and certain relationships can be got here, and we put a restriction. For this is one of the words, theta 3 can be twice that of the theta 2, okay. And then we made it work, and it was very, very nice working there, okay. And theta 2 can be calculated based on the h0 minus h1, and divided by L1 plus L2, so you can get that details, okay. Yeah. So then we could balance this guy on a tilting platform, so you can see that in the hip was kept balanced, okay, on a horizontal plane. So let us see the balancing. So it is compensating the left leg. Yeah. And that is, so that was sideways. The right one is backward and forward. So if it is forward, basically both the legs have to be changed. And of course, you have to keep the center of gravity also, because if the center of gravity is towards the edge of the foot or the feet to feet, then it is possible for the robot to fall backward or forward. Okay, so of course there is a maximum tilt that is possible. There's a limit to that because in this case the robot is not expected to sidestep. Okay, so it is just to balance with the hip. Okay, so this is a very interesting one. This I learned from my grandfather. Okay, that's a penalty kick. I did not learn penalty kick from my grandfather. Okay, so what I learned from my grandfather is that in my childhood we didn't have, not everybody had the wristwatches. So my grandfather taught me how to calculate time by having a road kept on the front yard and to measure the shadow. Okay, so if you know your height, the h is known, and if you look towards a ball, so you tilt the camera and you have a encoder or tilt sensor to know how much you are tilting from a horizontal, you'll be able to get this theta. So h you know, and theta you know approximately, because we are calculating and moving towards the ball by the, as far as the humanoid is concerned. So even if you don't know the distance, but you know the height that is fixed, and the theta can be measured by tilting. So you keep tilt the camera in such a way that you try to get the ball at the center of the camera, that is reasonable center. Then you'll have an approximate value of theta, and then you can calculate that distance. So you'll be able to move the robot towards that direction. So this is what I related to what my grandfather taught me. So for him, that temperature measurement was related to h. Sorry, that time measurement was related to h. Measuring h, you know h, and you measure d. So here you need only two variables to know the third. Okay, because it's a rectangular scenario. Okay, so it's quite simple algorithms. And the gate generation was one of the toughest one, and we all need to know that human walking is a risky business. Without split-second timing, we would fall flat on our face. And every step we take, it is we are at the edge of catastrophe. And of course, we have a wonderful brain evolved millions of years, and that's what it is able to. But you think of this, you take alcohol, or you have a problem. Sorry, touch wood. God forgive me. An issue with the head, in terms of cancer or something, or old age. Then how that will affect our walking. The legs and muscles could be the same, but you can have difficulties. Okay, so that's the beauty of it, and that's why we have to take care of our head and wear helmet when we are traveling, whether you are a pillion driver, a pillion rider or not. Both persons on a bike should wear the helmet. Also put the seat belts, whether in your front seat or back seat of a vehicle. Okay. So humanoids, the challenges are creating stable gait. So single foot and double foot support walking are possible. And because a large number of degrees of freedom, every degree of freedom is a actuation or a motor. Okay, so the kinematics and dynamics are complex. So we cannot have a lumped or a mathematical model for a humanoid robot. So if you look at a multi-degree of freedom industrial robot, it has got kinematic chains and dynamic equations, Lagrange-Euler method or Newton-Euler method, incremental, and there are different algorithms for that. And we cannot do that kind of a mathematical modeling. Of course, kinematic modeling is fine. Kinematical modeling doesn't include the masses and forces. Okay, so it's very complex, and of course, when you have to do the real-time control, you have to be very careful, and so it's a complex real-time control. So the stability is the most crucial one. So if you look at multi-legged systems, we know how do we manage that, and when we are not in a when we are tired, we feel like sitting because we want to reduce the strain on our brain and muscles. And when we are really tired, we cannot even sit. We would like to lie down. Okay, so postural stability is very important. And how do we go about? Now I've shown a picture here which doesn't have an upper body. So I would like to ask you, is it easy to stabilize two-legged system without a torso, or upper body, or more complex? Can someone speak or type on the chat window? It doesn't matter whether it is right or wrong. Do you think it is easier or complex? And nobody's saying anything, huh? You're all there, right?
Yes.
Yeah. Okay. Hey, I mean, maybe I should pick someone. Yeah, okay, Aditya. Thank you, Aditya. Yes, sir. Two-legged support system is complex. Now, I was saying two-legged system without the upper body. Is that, Aditya, thank you for sharing that. Very nice of you. Very nicely put. So I was asking specific to the two-legged system without the upper body. Okay, upper body below hip is only there, above hip is not there. So is that, Aditya, maybe you are the scapegoat today. Please say, it doesn't matter whether it is right or wrong. I will not continue till somebody says.
Yeah, yes, sir.
Aditya, good?
Sir, without upper body, the two-legged system means why we need two-legged system without upper body? There is no use.
No, I'm not talking about the human being, but can I make a robot to do that?
Yes, sir, we can. That is not much complex because
Okay.
we don't have to bear the weight of the upper body.
Okay. Anyone wants to counter what Aditya is saying? I gave an example of someone walking on a rope and having a long rope to counterbalance. So that is a clue. Yes, Adrien. Hey, come on. Yeah, thank you. Please speak more. Adrien.
So stability or balance?
Stability?
Balance.
Yes. Yeah. So yeah, you are positioning that. So it's actually it is more difficult to balance without the upper torso. Upper torso is a counterbalance actually. Okay. So these muscles are very important, and we have done it. Okay, we have made it work, but it was more complex. You can do it. So even in civil structures, if you look at Type I 101 building, so they have kept a very big ball at one of the top floors, and because of the wind, the building will swing, and the ball will have a counterbalance. Okay, so that is the same thing with the gimbals and other systems. Okay, so and even many situations we need the upper torso, but you can really make it without the upper torso also because we have advanced controls and mechanisms. But the weight, actually, you always require a payload. So the two-legged systems alone without an upper torso may not be always required. Okay, so what earlier said is correct. Okay, yeah. All right. So what is shown here is called the support polygon. Okay. So if you have a single leg, it is the support polygon is smaller. If you have two legs, it is bigger. And if you have four legs, it's much bigger. And if you're lying down, it is quite long and wide. Okay. So support polygon is very important. So then we have to understand the running and walking. So if you look at in running, there are situations where you will have only single support, but the center of gravity will be lying outside the support polygon. That is an unstable state. But it is okay. It is a transitional unstable state. Okay, so that is why it is so. While walking, you can have single or double, or depending upon the age or conditions, we switch from one to the other. Okay. So basically, we need to have coordination of time functions of angular positions. We also have, so we have to have position control, velocity control typically. Acceleration control, typically the motors will have an upper limit for the acceleration possible or velocity profiles. So we have to consider the specifications of the motors, how much it can. So there are difficult situations. So I'll show a video later on where the humanoid can fall onto the side, just like as if we fall, unconscious like. So how much torque change is required? So those are all the issues important. So these are the functions which are known as gates. Okay. So then zero moment point, which I mentioned, basically the zero moment should lie within the support polygons. So you have left leg, right leg, and you shift the CG over here and left, right. But some people can walk wherein this CG can lie outside the support polygon for a momentarily time duration. So, but that is an unstable phase. So we may assume when children start walking, we will say, oh, it's about to fall, but then the body is used to really compensate for. Okay. So, so this is the very important point. So SENDEP trajectory is to be kept track of. So the zero moment point is the point on the ground where the net moment of the inertial forces, and of course I did not mention till now the gravity force as well. So together the forces acting on the body are created by the actuators, and those forces acting on the body. Now when you have multi-body dynamics, it's not only the potential energy or kinetic energy, you'll have other forces like Coriolis force, centrifugal force, centripetal force, etc. Friction. There are several things acting on. Okay, and depending upon the speed of motion, so Coriolis forces may be less, because Coriolis force is the interplay of two velocities. Okay. So two bodies are moving at certain velocity v1 and velocity v2. How these two velocities will influence each other. So if things are moving slow, that's fine, but things are moving very fast, that'll be tough. So that is a point on the ground where there is no component along the horizontal axis. That means you don't slip. Okay, there is no force acting. So it will continue to stay in that horizontal position, and that is what is done by the moment point is zero. That's a zero moment point, and that is to be managed for stability. Okay, so and there are two stabilities, static and dynamic. So necessary and sufficient condition is that the zero moment point to lie within the support polygon at all stages of the locomotion gauge. But there can be certain portions where it can lie outside. That is a dynamic stability shown on the right side picture. So from a mathematical point of view, we are inverted pendulums. And I remember my PhD thesis, one part of it was on cart pole balancing. There is a moving cart and a pole, and I had to position the cart in a particular position and while keeping the vertical pole vertical. And I used a neuro-fuzzy system, adaptive network-based fuzzy inference system, ANFIS, at that time. So I was working on the software side, theory side, on humanoid during my PhD, though I didn't have the luxury to get into humanoid at that time. So this is the inverted pendulum model. And then if you have multiple, so here only one link and one mass, that is the center of mass, but you can expand this to multi-link systems, double inverted pendulum, and multiple scenarios, and the masses are distributed. Then it is a multi-body kinematics, dynamics, and control. Of course, why do we need to do all this? Because there are a lot of interesting applications where helping people to walk. And if you have to do strenuous works, lifting, how do you go about? So also sometimes we see our elderly people at home, they'll become bedridden and we have to take them to the hospital, to the toilet or other places. It's very difficult. Or even lifting them up from bed to a wheelchair, it's not easy. So people use exoskeleton. So on the right side is exoskeleton used. Okay. Also, there are people with the complete lower body not there because of accidents, or they're also due to stroke. There are issues. So when you have a stroke, it's very difficult to even move the little finger. The pain you have to endure will be enormous. So what people do is, can we have a support system to make this bending to happen? So that when the bending happens, the neurons are excited and reconnections can happen. And then there will be a regeneration possible, and you'll be able to get into a kind of reasonable normal life. Okay. Also, getting the exercises. So if due to stroke or some other stuff, you cannot close your jaws, basically, the fingers, you can have a mechanism to help. So these are all very important and useful things. Also, rehabilitation is very important. So I went through this. I lost my muscles because of my frequent travels abroad, economic loss syndrome. So 8 months I was on wheelchair. It was very difficult for me. And I'll tell you, when the muscles are down, you'll be frustrated because we used to walk around. Suddenly, a freedom is lost. So it's very painful to get back to work. And I'll show you one example what Kerala requires. There are a lot of people who are suffering. And why I agreed to this STTP is that at least someone among you will start working on it and come up with a affordable solution for people who are in need. Okay, so please do consider that and work on it. So we have developed a number of humanoid robots, and the sensor system is very important. So for sensing, we used in the initial designs a camera kept upward and a convex surface, so you get 360 degrees. But what you get there from the image will be not on a plane. So we have to transform these points into a two-dimensional space. And what we did is that we used genetic algorithm to do the mapping and identifying the mapping coefficients, okay, how to map it, okay. And this was very useful, and I'll show some videos where this is used, where it can track the ball and it can dive to one side to save from getting a goal, okay. It's very swift. And this is another work. This is done by one of the students from Kerala. He did PhD, Pramod Kumar, and after his we published a book also, and he went to US, MIT for postdoctoral. He worked in Obama's brain initiative. We used the model of the visual cortex in this work. At that time, deep learning was not there. And we used artificial neural network, fuzzy logic, as well as there is something called rough sets. Rough sets is a very interesting concept. So in traditional binary set, the set is well defined, the elements are well defined. There is no ambiguity. But in fuzzy logic, the set can be defined or set need not be well defined. So you can have a fuzzy set with defined boundary for the set, or with ambiguity in the elements, how much it belongs to a set. So it is not a fully member always. So in binary, either fully or not fully. So in fuzzy, you can have partial memberships. That's why 0 to 1 you can have. It's not probability, by the way. Probability is totally different. Probability stands, and it is unknown, but fuzzy is known. A typical example we give is that if you are alone in a desert and nobody is around, suddenly 2 bottles pop up from the sand. One, it is written, the probability of this liquid being poisonous is 0.5. And the other one, it is written that the fuzzy measure of poison in the second bottle is 0.5. So which one you will drink? Let me ask this question. Can somebody say something about it? Maybe I will talk about that when I take the AI thing, okay? So, okay. What do you think about it, okay? So rough set is another category where the set is well defined, elements are well defined, but the elements sit in the boundary. So if you look at India and Pakistan, the issue is the Kashmir. Kashmir is well defined, India is well defined, Pakistan is well defined, but Kashmir sits in the boundary. So when you have a problem of that kind, you should never solve the problem of Kashmir. You should solve India minus Kashmir and Pakistan minus Kashmir, and we should have bilateral ties, and Kashmir should be kept outside of that. Of course, with the removal of the article, there are changes, but I'm just giving an example, so don't take it in a political manner here. So we use a fuzzy rough sets here for hand gesture recognition. So we have a database which is available for you to download. Again, for the first time at that time, we had created a database of hand gestures against complex backgrounds. Till then, we had backgrounds which are plain. So we used this algorithm and we got very good results, okay? And so if you need to know, you can get the database from my website, and also the book is available through Springer, okay? Yeah. Kinect was attached to the humanoid and externally as well as on the head, and we try to make a humanoid to react to gestures. So this video is where the Kinect is kept on to really track the human, and some arm movements are there, and then accordingly the robot is behaving, okay? So this is basically imitating, and very interesting work, and there are different gestures given, okay? Yeah. So we have developed a number of humanoids, and we use CAD, MATLAB, sim mechanics systems, ADAMS, and we also use robot operating system. Lately, we have done the simulations. We have done a lot of work in that space as well. And so initially it was purely hardware without software, because in 2001 when we started, we didn't have the luxury of those software systems. But later, softwares came very good in that space and rose lately. So this is a humanoid robot from Fujitsu, which I bought some time back. So my former student's fiancé wearing a measuring tape, and then all those motions are transformed to the Fujitsu humanoid. But you have to see that the degrees of freedom of the human hand is different from the number of degrees of freedom of the humanoid. And we could make both arms do it. And doing both with both arms, you have to do some kind of a symmetry, and the angles for the different joints have to be managed well. So this is the genetic algorithm-based vision at the head, kept upward camera, and then it is able to track the ball. And the immediate video, you see how easy, how quick it is to react. So GA is offline learning, okay? It's not online. So once you learn, it is quite fast. And this is to pick it up and kick the ball. Yeah, and then this is, I mean, some of these works are final year projects, okay? Fourth year projects by single student, okay? Not group projects. So that is skating. So the balancing is very important there. And this is a scenario where they dance. Yeah, I should bring these guys to India a lot. So we have won a number of awards, and 3-4 years of hard work. I could work with Ambarish, who was with Honda Simo at that time, and we published a major reference work. And currently, my students are working on the Navo humanoid robot. And human-robot interaction is very important, and this is not very costly. So if you wish to start, you can. There is Bioloid robot from Robotics Korea, and that company was a spin-off from the lab where I worked in South Korea. You can get it for a few $1,000, so maybe 1 lakh plus or minus Indian rupee. And I think someone from Amrita bought it. Yeah, so he came to Singapore and bought it some time back. So, but this is a bit costly. It's about 5 to 6 lakhs, but it's quite good, and it can interact. It can identify gestures. It can have multi-sensor fusion. So we are working on it, and there's 4 students are working on this now. And also the measuring tapes, which I mentioned, you can buy this. You don't have to buy the entire thing, but you can buy some and get the data there. And that's what we did earlier, which I've shown. Okay. But I would like to say something about this. Why, as I mentioned, there is something which hurts me a lot. So this is a guy from Ottapalam. He contacted me some time back. He was an engineering student in Bangalore, more than maybe 15, 20 years back. And he was traveling after first year exam. Pickpocketers attacked him, and he resisted. They pushed him out of the train. He got a cut at his back, neck. So he's quadriplegic below his neck. He cannot move any of his body parts below his neck. So he contacted me, and I gave him a job. I started a college which I had to stop post demonetization because of cash flow. I gave him a job working from home. He also got a job from Singapore and Canada. He used voice activated systems to manage the computer, and he needs help. So his mother and sister helping him. So he also asked me whether he believes that if he does some exercise with his hands, his neuronal system will come back one day, regain, and that's hope. So my students worked for him and developed a voice activated sensing, exercise system for his arm. Okay, and it's very tough. Okay, because initially, because the muscles are not moving, there is so much of stiffness. Okay, so the force you exert to start with will be you require more. But the moment that is started moving, then you should not have that force, because it will really hit you on the other way. So it will be extremely careful. We developed that, and we have tested that to him. But unfortunately, because I was closed down that college, I could not continue with that. But if you have, if you can support, please do. Okay, and give such projects to people. Don't do something like going to the moon and Mars. What's the point? No use. So I sincerely suggest to give projects to take care of the locality needs, the regions. Okay, so if it is Kerala, Gujarat, Tamil Nadu, Andhra Pradesh, or Bangladesh, or Haryana, you do it there. So look at the problems, okay, like that. So in 2009, people predicted by 2020, we'll work with robots, and that is what is happening. We have to now share our space and time and resources with the robot. So there's a Baxter robot, which I mentioned. You can work with it, put your head in its workspace, which is not possible with any other industrial robot. So they really made a change in that. Baxter is less precise, but more adaptive and safe. Okay? So arm can feel when it is about to hit something. Okay? Cost is less too. Okay? And you can move the arms to program it. I just put this up towards the end just to tell you the way it is. And I'll be talking about AI day after tomorrow. So that is to give a precursor. So machine learning is so hot and wonderful. So I would like to stop at this moment and then ready for questions. Hey folks, Deba, nobody should be allowed to leave without asking questions, okay? That's a punishment. Don't give certificates to anybody if they don't ask questions. Okay, so Sahil Gupta, very nice of you, Sahil. What is the basic concept requirement for making a robot? So what kind of robot are you asking, Sahil? Is it a mobile robot, aerial robot, legged robot, or humanoid robot? You can unmute, or you can a mobile robot. So now mobile robot is a wheeled mobile robot with wheels or legs. These two are different. Legs. So then now how many legs? 2 legs, 3 legs, 4 legs? 2. So 2 is a humanoid robot. Okay. So if you want to work on a humanoid robot, my suggestion is don't start from scratch. You buy. That's what the Biolite robot is better. Because so much is required to develop to really have a stable control gate. Of course, if you can have I think in India, BITS Pilani did very well. And I know some NITs have done, but not too many. And there was some development. I may not know across India, by the way, but in Tamil Nadu also, I know one guy who did that. So if you want to develop, definitely you have to have 2 legs defined. How many degrees of freedom? Definitely, minimum 3 is required. But we had 6, 3 at the hip, 1 at the knee, and 2 at the ankle. Okay, so 6 plus 6. Then you have to have the upper body, and upper body also cannot be rigid. So you have to have the balancing act. So you can move forward or backward or left and right. So 2 degrees. That's the minimum required. Without the hands, you can start. So then, so you have to decide how much torque will be there for the motors. So a hip motor torque requirement, knee motor torque requirement, ankle motor requirements will be different. So you have to use torque motors, which I mean a bit costly. So that will help you. And then, as I mentioned, you can try to have certain heuristics, like keep the knee angle twice that of the hip as well as the ankle, and then you do modify the gates, and on one leg move forward by tilting your body forward, and like that you do. So I'm not sure whether that is what you are asking, but you have to have a control, CPU, processing unit. You have to have interfaces. And one important point which I did not mention is if you have 6 legs on one leg, 6 motors on one leg, you have to have a bus architecture. So we use CAN bus architecture, and there will be slight delays. So you have to compensate for that. So left leg and right leg, okay? So Sahil, did I satisfy you or something missing? You can unmute and speak also, Sahil. I hope, Sahil, can you say you're okay with my answer? Okay, anybody else? Okay, Yamuna. Okay. Yamuna, thank you, Yamuna. Yamuna, you have anything to ask? No, sir. Thank you, Yamuna.
Hello, sir.
Anyone else? Yes.
Sir, hello, I am Manish Kumar from
Yes, Manish
MNIT
Kumar.
Allahabad. Sir, I designed one humanoid robot in my BTech project.
Wonderful. Congratulations. Very nice
No,
of you.
sir, I could not succeed because there is a problem in synchronization of leg. When one leg is moving forward, the balancing of other leg is not synchronized.
Yeah.
And for that, I used a servo motor.
Ah.
So could you please tell me something, there is any solution, and how to read that solution from anywhere? Could you provide me some source?
Yeah, so there are a lot of published works in that space, okay? How to generate. So we have a work where we have used simulation to start with, and we use genetic algorithm to optimize the gate sequences, okay? And then those angle positions, angles change with respect to time. So it is a polynomial equation for those angles, okay? Those will act as the set points for the motor. So you can create the set points, which is optimized in a virtual space or in a simulation. So initially we started with, at that time, from CMU, Carnegie Mellon University, there was a software platform to do the optimization of the gates. So that's how we started, okay? And Now you can do what you can do is you can, if you can buy the Navo humanoid, I mean, it's all taken care of, already there. It's a beaten system now, as far as the walking is concerned. It's a bit costly, but then you can do other things, human-robot interaction and all that. But in robot operating system, it's a freeware. It's not an operating system, not a primary operating system. You need Ubuntu Linux. On Ubuntu Linux, you install robot operating system. You can, there'll be libraries to import a humanoid and other robots into the ROS, okay? And you can start working on there. So I suggest strongly to use a simulator, or at least even MATLAB sim mechanics, you can do wonderful things, okay? And there you work, not on the hardware stateway, okay? But very nicely, I appreciate Manish. The attempt is very tough. In fact, I had one of the very good students to start with, because he aimed to do PhD in Stanford. And the Stanford professor said, you go to Singapore, you do it, and then I'll take you. And he did it for me, okay? And then another couple of students, they did extremely very good individual works for that matter. Great, yeah. So then, thanks, Sahil. Okay, Idreen Varghese. Okay, could you elaborate about artificial emotional intelligence? Okay, okay. So we can have emotions, okay, just like we communicate through the icons, emoticons, right? So in a humanoid, so the humanoid which I've shown towards the end, the Navo humanoid, it can change the colors at some points on the face, and it can change the eyes, color, and it can what is visible for a human being. So some changes, and it can show anger, it can show happiness, etc. But it is artificial, it's not real. So in our case, so currently what we are working on is that for the Navo humanoid, we have collected large number of human facial expressions, and we are learning, using deep learning, we are learning how to categorize or classify the different kinds of emotions. Now the idea is, once you learn in deep learning, we will pass that to the humanoid, and humanoid is facing you, the robot will be able to recognize that, oh, Professor Prahlad, are you angry? Are you happy? Or is that disgusting? Something like that. But that is recognition. But if you want to have artificially create, you have to have the mechanism. So it can be on a screen, and you can change in a two-dimensional video. You can change, make the facial expression change. So is that what you are asking, Idreen? Okay. So Fenil Sunny, possible to build a robot with only chemical reaction. I heard some universities trying to build it with no mechanical parts. Okay, there are different attempts. Okay, one attempt we did is without using digital circuits. That's a biomorphs. Okay, so we have made artificial neurons, analog neurons, and we made robots to walk. Okay, that is possible, but it's very complex, and we don't have millions of years to really make it evolve to millions of neurons. Okay, now there are, if you look at robots work on electric motor, pneumatics, hydraulics, and several things. Now, chemical reaction. So I don't know specifically about this particular example you are mentioning, but if it is chemical reaction is for, see, we have artificial muscles being developed. So the muscles can contract or expand, and based on that, the muscle's strength will be different. Now, one of my works for my PhD was active suspension systems. Of course, it was theory, but later on people, developed a liquid-based suspension where you change the polarity or between two positions, then the liquid's viscosity will change, and then the viscous friction created by the liquid on the moving parts will be different, and you can have damping created. But it's only positive side, one side, not the other side. Okay, so if there are different attempts in terms of chemical reaction or artificial muscle-based systems. So, Fenil, is that what you are trying to ask, or something else, or is it something like just like our hormones, we are trying to do something? Because without mechanical parts, it cannot exist. I mean, I didn't mean that. I mean, what I meant is without a support structure, the system cannot exist. So even for a biological system like us, we have our skeleton inbuilt. That's why we are able to walk. Otherwise, it's difficult. So because we want to have payload and all. So I'm not sure whether Fenil is talking about that. Okay. 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 Any other questions, folks? Jason, yes. Any remark on Sophia social? Yes. Okay. So Sophia could really do that. I think this is quite related to Adrian's question, humanoid robot, and of course, a lot of work has been done, and emotions, and there is something called the replicas of human beings, and there is an issue. It's not a marketing stunt, no. So of course there is always marketing part of anything for that matter, but it's not that. It is a real attempt. So there are human-like systems. I did not mention about the issue there. There is a uncanny valley. Okay, when we create artificially anything more close to a human being, initially we'll start liking it, but there is a point where we will start disliking it. So we like comics, we like line drawings, we like Simpsons, right? We like birds, we like all the comics in Pogo or Cartoon Network. That's okay for us. But if you look at the movies like Cuban Girl or Polar Express, they try to create human-like artificial creatures, and it miserably failed because we are very sensitive to a unnatural movement of our muscles and eye movements and coordinations. But this year, Samsung has come up with a beautiful virtual human-like virtual avatar, which can be, you cannot differentiate that from a real human. Okay, I don't remember the name of it. Okay, and people are using that as a digital version of it. So quite good. Okay, then Nigel Chaturvedi, can we make an artificial brain govern human body just like, I don't know, Nigel, I'm not Einstein, but I think eventually it may take time, because if you look at the brain, one of my former students did a work that was 15 years back. At that time, I did not follow the work later on. A biological neuron had 14 different highly nonlinear characteristics. Okay, and we could model only, we did the 7th modeling. We could not model the rest. Or rather, it can be individually modeled, but you cannot combine these together. That's the beauty of human brain. And if you have to have that level of modeling, so even in artificial neural networks, what we are doing is discretization. Of course, continuous signals can be created using analog neurons, which we have done for 16 neurons, 32 neurons like that. Okay, but I don't think it is very easy, but the best thing will be to, forgive me if I am crossing certain ethics points of view, take the human brain and utilize it. But I'm not sure how that will be possible soon. Maybe it will take time. And Fennel Sunny, yes, a search about it and it has been made October. Yeah, correct. Thank you. Yes. Thank you, Fennel, for coming back and sharing that. Wonderful. Yes, folks. Any other questions? It is 1:29 in Singapore time. Okay. Jay Singh, how India will compete with other countries like China, USA, Sweden in AI technology? Okay, that's a very interesting question, Jay. Okay. So in robotics, I'll tell you my first humanoid robot company in Singapore, 2004, we started. The first humanoid was sold to China, long back, 2005. And 2019, I went to China, Shenzhen. We were specially invited for one of the best robotic competitions in this world called RoboMaster. Just like World Wrestling Federation, all kinds of lightings and audio visual mechanisms. You don't believe it is in a stadium, football stadium kind of thing. Okay, and they made the engineers for the first time heroes. And so we have teams working for them. And what they have achieved there, commendable. Now I've been touring India mostly, about 15, 20 speeches in India every year. Nobody really bothered about hardware. Everybody went to IT. India made a lot of money in IT. But these IT companies did not invest in AI. Some are investing, but not everybody. And they are going to face a big challenge with robot process automation, where many of the things can be automated. Most of the things, the call centers will vanish in no time. Okay, that will go. You don't need people to do that dirty job. Okay, I'm sorry to use that word dirty. Dirty is not to denigrate the humans who are doing it, but with respect. Okay, and now AI, what I see is that there are enterprises, startups, young minds are doing wonderful jobs. But I helped one company in Bangalore some time back on something, and they did not come back to me. I'll tell you, this is a very interesting question, Jason, you are asking. Lately, I'm presenting to big multinational companies about what is possible with Industry 4.0. And you know what are all people sit there? The CEOs, the CTOs, the director board, they all sit in, not in one, 200s and 300s. And I had a number of presentations in the last 6 months. But when it happens to, the institutes like this, how many of the big guys are sitting in this? Will AICT sit in? Everybody sits in somewhere. No, not many are sitting. Our ministers sit in? No. So we have to change all that. So, but I think the current trend in what I see in Delhi, there are a lot of funding for it. So you go for it. So there is some interesting fund which we are trying to seek through an Indian entity as well. So there is big hope because you can learn from scratch and online resources are there. Nothing stopping you except your curriculum, except the syllabus, except your teacher. Oh, sorry, you are all teachers. The syllabus and universities not doing enough, because you know how much change we do every year. So you should change it. You try to incorporate, you learn yourself. Okay, so okay. So now the next question is Narayana. I have seen online amoeba-like robot. Yeah, that is possible. Yes, as I don't know much about it. So there are artificial creatures being created and people are working on it. So I don't know much about that, Narayana. Sahil Gupta, what are you working upon currently? Okay, currently I'm working on the Navo humanoid robot for human-robot interaction and human emotion recognition and stable gaits, interaction, and those aspects are being worked. But my majority of the work is related to AI applications. So deep learning, big data, all those aspects. and we get a lot of data from industry. Yeah, good. Thank you. So I suggest all of you to learn. So Google Colab is one which I want to talk about when I talk about AI, where you can learn a lot of things. TensorFlow online. So you can learn AI. And my son took 3 years off after his undergraduate. I supported him, and he studied AI, both breadth and certain level of depth. You cannot learn, it's an ocean, everything you cannot learn. So my suggestion to you is remove your hat as assistant professor, associate professor, or professor, or head, or whatever it is. Start learning today AI, and it is there everywhere. I'll tell you, my colleagues in linguistic department, they are assistant professors and associate professors and professors. They've learned AI lately, and they are using AI in their research. Mathematics department is doing, a civil department is doing, mechanical is, electrical, electronics, everybody is into. So arts or science or technology or psychology or linguistic or book publishing, everywhere it is coming. So all book publishing, a lot of outsourcing to India will stop. And India will, unless India positions very well in AI, India will lose a lot. So you all have a responsibility to really create that environment. Yeah. Thank you. Any other questions, friends? Folks? Thank you. Yamuna, very nice. Okay. You should write, you should say that, okay? Yamuna, when you feel something is good, it's very important to say good things. We all say bad things all the time, okay? So when you see something good, it's not about me, okay? I don't care about myself beyond a point, but you should say that. So Yamuna, I really like what you mentioned. And Jay Singh, thank you for saying thank you. Okay, share email. Okay, I'll share my personal email. So drvadakepat@gmail.com. Okay, so I'll tell you how I work with respect to email. If you ask me how to apply for NUS, I will not answer. Everything is available online. Okay, that's not my job, that's your job. Okay, and if you want to know which university in Europe is good, don't come to me. You should do the searching. Okay. Okay, so whatever is available on the internet, you should learn. You should do, before asking a question or email me a question, should spend half an hour to really understand what you are asking and whether it is available on the internet, because everybody's time is very crucial and important. Okay, so thank you. Yeah.
Thank you so much, sir.
Thank you. Yes. Is that
Dear participants, no, sir, myself, Swati. Deepa,
okay,
miss, are you there online?
Sir, yes, sir. Yes, ma'am. Thank you, sir. Thank you so much for the valuable time, for sparing your valuable time and for this very nice session.
Thank you.
Yeah.
Okay. So all the best to you, and we'll meet day after tomorrow. Right? Yes. All the best.
Yeah. See you.
So I will leave now. Okay.
Yes, sir. You can leave.
Okay. All the best to you. Take care, and take care of the COVID situation. All the best. Thank you very much. Bye bye.
Thank you so much, sir.
Thank you, Nikhil, for saying that. Thank you very much.
Yes.
Dear participants, we would be starting with the next session shortly by 11:10 a.m. Meanwhile, please fill the attendance for session 1. As we have already informed, certificates would be issued to all those participants who attain an attendance percentage of 80% and above, and also who score a mark of 60% above for the online test that would be conducted at the end of STTP. Dear participants, we have already sent your group members details regarding the project that we had discussed yesterday. Please see to it through your mail as well as through the WhatsApp group, and kindly discuss among your group members for the same. Good morning, Jeetu sir. Are you online?
Yeah, good morning, Deepa. Can you hear me?
Good morning, sir.
Yeah, am I audible?
Yes, sir, you're audible.
Okay, thank you. So let's when do you want me to start?
Yeah, we can start by 11:10. Just one more minute to go. Sir, you can just try sharing your slides.
Sure. Can you see the screen?
Yes, sir, it's visible.
Okay.
So, Miss, we can start.
Dear participants, welcome back to session 2 for the day. Current session would be handled by Mr. Jeetu Joseph, Enterprise Architect, Robotics and Services. Mr. Jeetu Joseph, Master in Computer Applications, is an enterprise architect working for Tata Consultancy Services under the Robotics and Cognitive Solutions Department. He has over 17 years of IT industry experience, which includes providing enterprise solutions for various customers across the globe in AI, big data analytics, cloud services, business intelligence, and data warehousing technologies. Mr. Jeetu is an expert in handling complex business problems, providing innovative solutions to various business units across TCS, and also advisory services and thought leadership on latest industry trends. We welcome you, sir, to the session.
Yeah. Thank you so much for that great introduction. And good morning to all the participants who have joined this particular meet. So the main intention of today's session, right? We have heard a lot about AI in terms of different discussions, forums, in terms of different articles that are available on the net or on any kind of magazines, right? But have you really seen the implementations that companies like TCS have done, right? So that would give a different perspective altogether. How AI is being implemented in real world solutions for some of our prestigious customers across the globe, right? So that's what I am going to cover as part of today's session. So altogether, what I have is around eight or nine real world use cases, which we have done for specific customers, right? So let's start with the first one. It's nothing but it's called a surgical robot. So this is something which we have done for one of the leading medical devices company. They have offices across the globe. So one of the pioneers in creating, really excellent and automated solutions for performing surgery. They are also involved in creating medicines, right? They are in the pharmaceutical industry. They are in the medical device industry. They have different products that we use on our day-to-day life, right? So they, they are building a robotic device which is capable of performing surgery on patients, right? So when I say robotic devices, there are many robotics devices available in the market these days to perform the surgery, and this is one hot area that is becoming more and more predominant, right? Especially in the areas of robots and AI. So they are building a very specific kind of system, where in which the surgery would be kind of fully automated, and they want to perform end-to-end kind of data analysis, right? As and when the doctor is performing any kind of surgery on the patient, they want to understand if the device is functioning well or not, right? So if they get to know that, okay, the robot who is going to perform the surgery is not performing in the right way the surgery is supposed to do, then they can take preemptive measures, right? In order to probably correct the surgical procedure or get some doctor to intervene in the middle, right? And then probably take over the surgical process. So they have a number of use cases related to this on the surgical space. So all in all, what happens is they have different robotic arms, right, like this, which will perform a specific set of surgeries. So to the robotic arm they will attach various devices, right? There are certain devices which will perform just a cut in the body. There'll be specific devices which will actually perform an insertion in the body. There'll be certain kind of devices which will actually perform a stitch operation, right? So all these devices, right, it is getting hooked onto the robotic arm, and then they have different sensors, neural network cameras, and everything embedded on this arm, which will eventually give a lot of insights about the whole surgical process end to end, right? So these, when I say neural network cameras, these are very intelligent cameras which can detect even a minute set of movement on the arm. When the surgical process is supposed to be done on a specific body, let's say the arm has to move to certain direction, and if it has to apply certain set of force on a body to perform a cut, right? Let's assume a scenario where the arm doesn't work in the right way and it applies more force than it is supposed to do. In that case, what would happen is it will perform a deeper cut on the body, and it is going to cause internal injuries to the internal organs, right? So the whole intention of building an AI platform for this is we want to really understand, right, how the device is functioning. When I say the device is functioning, it might function well in the first place, but does it function well in the second place, or is it going to function well even after 10 times of usage, right? So for all these analysis, we have data coming in, the real time series kind of data coming in from sensors, the movement of all the machines being captured through neural network cameras which are embedded on the robotic arm. And then in real time there are systems which are deployed on the network which will capture all this information and will stream all this information to a cloud platform, right? So in this particular case, we have used Azure. Azure is Microsoft's the cloud platform. So there are different services which are available on the cloud platform which we can use for performing analysis on the data, right? Building machine learning models or deep learning models, or performing deeper insights on the data. There are different kind of services which are available on the platform. So some of the key services that we are using, especially to perform data analysis, right? We are using the Azure Machine Learning Service. It is actually a service which is provided by Microsoft, which has a lot of pre-built machine learning models available. And then we have something called as Azure Kubernetes Service, which is nothing but a containerized platform for performing all the data processing needs, right? And then we have something called as container registry, where we keep all the images that we are actually building, or in fact the models being embedded within the image, and we can store it on the container registry, right? So the whole idea is different surgical robots are being deployed in different hospitals. We also want to analyze how the devices that are being deployed in the hospitals are being used, right? So there are mandates being provided by the company that, okay, if you are buying a product from us, the product should not be used kind of more than 10 times, right? The sterilization time frame or the period for a particular device is not more than 10 times, right? So that's what the company mandates. So after the 10th time of performing the surgery, the device has to be newly procured, right? But these are all expensive devices, but certain countries would try to basically reuse the same device again and again beyond 10 times. They go up to 20 times, 30 times. So that would actually create a problem when it comes to surgical process and all. So there are automated systems in place here which will actually find out the how much time the device is being used. It will actually try to capture the sterilization life period of the device. Then if any hospital is trying to use the device more than the stipulated period of time, then the company who is selling the device would get an immediate notification, and they would be able to sue or charge the hospital who is actually performing the surgery. So there are a lot of use cases and innovations like this which is happening on this area, and also the device, right, as and when the surgery is being performed in a human body, they have certain specific requirements to keep on monitoring, right? Like across the globe, they have deployed a lot of surgical devices. They want to keep on monitoring all the surgery that is happening in real time. So what happens is, if let's say a surgery is going on in one particular hospital, and there are certain adverse events occurring as part of the surgical process, right? They will be able to quickly take remedy measures, right, by informing the doctors about the faults that are occurring in the surgical process. So we had been hearing different various news about robotic surgery being a failure in certain cases where patients internal organs have been specifically taken a toll on that and all that, right? So with such systems in place, the new age kind of surgical robots in place, many of those issues can be avoided. Okay. So for us to get the data onto the platform, create certain level of machine learning models, deep learning models, and all that is quite challenging, because when I talk about data, there are if you take one hospital itself will have multiple surgical units, and each unit there might be surgery going on in parallel. And if you take the number of hospitals where this product is being deployed, right, there are huge number of information that needs to be gathered in real time, right? So when we create or deploy some of these products, right, these are some of the key challenges. How do we gather the data in real time? How do we perform analysis on the data in real time? How do we predict, like, if the system is behaving in the right way or not, right? So these are some of the challenges from an implementation perspective. But yes, thanks to the cloud platform and the new age technologies that are available in the market, which can quickly get all the data from different systems with utmost speed and with utmost data loss, right? Data is something very important. The data cannot be lost in transit, right? So there are systems in place which will help us do that. And once we have the data, we run certain machine learning models on that to find out the information that is residing on the data, and then come up with some kind of prediction model. Also, all these technologies, right, which are running on this platform, the inference which is getting in from the data, right, it is not just about the data analysis. There are so much other information which is residing on the system, like how many surgery has happened, how many hospitals are performing surgery, what are the number of surgeries that are successful. So all those information, the company who is owning this product, right, the management of the company, the CEOs of the company would like to get all those information in a dashboard, right, in a graphical format. So we have certain visualization tools or layers which are being built, which will actually connect to the platform, fetch all the information, using the current information along with the historical information that is available. We'll be able to plot all the information graphically and provide greater insights about the data back onto the company who is owning this platform, so that they can take crucial business decisions on how they have to sell the product, how they have to market the product, or what kind of refinements they have to perform on the product. So
only basically there are just 3 main questions in this module.
is there any question? Hello?
Sorry for the disturbance, sir. You can continue.
Okay. Right. So as I was saying, the visualization layer, right, gives a lot of insights for all the the business managers, right, who is looking for the product's future, right, so that they can take crucial decisions by looking at all the dashboards or all the information that is available on the data, on the data analysis that are being done on the platform. Right. So this is one of the real world use case that we have done in terms of building a surgical robotic platform for one of the leading customer in US. Any questions here?
Jitu sir, there is a suggestion in the chat box that could you please put it in full screen mode, the presentation?
1 second, let me see. It's clear now?
Yes, sir. It's good now. Okay, sir.
Okay. So then I'll move on to the next use case. The next one is about printer log analysis. So this is one global company, a printer manufacturing company, which has printing machines, be it office or be it home, right? They have manufactured so many printers and they've sold it across the globe. Right. So, most of our homes might also be using the printer which is manufactured by this particular company, especially most of the bigger giants, we buy printers, especially from this particular company. So they are the primary requirement, right? So every printing device, when we are making a print, right, a print of a particular document, internally the machine, right, is capturing certain level of information. Right, about how many pages have been printed, and then it will also keep a log of the capacity of the ink that is available on the printer. It will also try to capture the printer quality, right, and the if you're trying to attach to the printer any kind of duplicate parts, right, it will also try to identify if there are any unauthorized parts that are being attached to the printer device and all. So the all these new age printers, they are capable of self-detecting a lot of things, right, especially with respect to the hardware and also with respect to the quality of the printing, that process that has happened, right? So it is capable of self-detecting all those. It's a matter of just connecting to the internet, right? The moment you connect your printer to the internet, it will keep sending all this information without our knowledge onto a central server within the customer, right? So in this case, this is a US customer. So any printing operation that we perform here, and once our printer is connected to the network, it will capture that information and then it transfers onto the server without our knowledge. So the whole idea of capturing this data analysis, right? Because a couple of reasons, right? One is they want to identify if the print quality, right, is deteriorating over a period of time, mainly because of a technical fault of the machine, or probably because we are using some kind of ink which is of low quality, not a standard ink provided by the printer company. right? So if if let's take the case of countries like India and all, where we use a lot of printer inks which are not being really provided by the manufacturer, because the duplicate printer ink cost is very less, probably 1/10 of the actual printing cost, right? So the idea of these printer companies are to basically find out in the regions where duplicates inks are being more frequently used, what they can do with that, right? So if they find, let's say in Kerala, in a specific region, a lot of duplicate inks are being used, the next option would be for them to supply the actual authentic printer ink for a lesser cost, so that the number of duplicate or faulty inks that are being used gets reduced, right? So if they have to find out all these information, the only way is to get information or the data which is being available on all these printers locally being deployed on the system, right? So as I said, without our knowledge, a lot of information gets captured. Everything goes onto a central server, and once the data is being captured on a central server, they have certain big data kind of machines, right? Data processing machines, which are called clusters, deployed on their network itself, which will actually stream this information from the servers and will keep getting accumulated here. Okay. So once the information is available on their network, right, the next process is, how do we analyze the data, right? How do we create some kind of machine learning model on top of it, right? So for that, we have a collection of softwares or system in place which will perform the whole data analysis end to end, right? So if you see this particular mapper, this is it's a Hadoop cluster, right? So Hadoop cluster is nothing but, for those who don't know what it is nothing but it is a distributed data processing engine. Wherever we have needs for analyzing huge volumes of data, right? We will not be able to directly take all those huge volume of data and use some kind of Python program to perform the data analysis, right? It is just not possible. So when I talk about huge volume, the volume of data is in terms of terabytes and petabytes and all that, right? So there are systems in place which can process data in parallel. So if I try to process the data in one single system, then either my application will go out of memory, my application doesn't go out of memory, at some point of time the machine is going to crash, right? So in order to avoid all that, the distributed data processing terminology is in place, right? So instead of one machine processing everything, a collection of machines, right? There might be 100 machines, like Yahoo and all process their data with machines, with a cluster of machines which are more than like 3,000 machines together, right? So they have a 3,000 odd machines put together called as a cluster. So so that's where this Hadoop is coming into picture. Hadoop is a distributed data processing framework, wherein which the data, when it is required to be processed, it will be processed. Each of the machines which are there on the network will process a chunk of the data, and finally the everything put together, you will get the final data analysis. So if you're trying to process on a single machine, and if it is going to take 10 days to process or 20 days to process, if we process on a Hadoop cluster, we can process it within an hour or so. So that's the reason where we use technologies like this. So Mapper is nothing but it's one of the Hadoop distribution. There are other Hadoop distributions like Cloudera, and once on the cloud, right, we have certain different techniques for data processing. Like on Azure, we have Azure Databricks, so that's another technology which will help us to process the data in a distributed way. So there are a lot of technologies available in the market. Whenever we choose a particular technology, we will analyze, we will work with the customer, analyze their requirement as well, and then there are different parameters that will finally decide on picking up the right technology. One of the parameter could be cost. The other parameter could be the interest of the customers to move towards cloud and all that. Okay. So on this cluster, we have technologies like HBase. HBase is a system which can actually process semi-structured or unstructured information, right? It's a NoSQL database. So from here, some of the information which is coming in is in a specific text format, which can be processed only using systems like HBase. And then there is something called a Spark, which is very widely used technology now. It has a lot of capabilities to process everything by keeping stuffs in the memory. HDFS is nothing but the storage medium. UC is nothing but the workflow, which the end-to-end processing which happens on the system will be controlled using technologies like UC and all. So here, the key takeaway is, the Spark, which is one of the key technologies basically used in the data analysis world. Most of the companies are using it. There's huge requirement from a job opportunity perspective, right? So in the end, once we process and analyze all the data, the requirement which the end customer is expecting, right? Basically analyzing the log, able to detect all the faults ahead in the system, and then analyzing the quality of the printer and taking proactive actions on supplying the printer. On supplying printer inks for a lesser cost, or even procuring parts, right? So let's take the case. So this point number 2 is very critical, right? So let's where a couple of printers that are supplied to the Kochi region. There are certain fault in a specific component within the printer, right? So if they get to know well in advance, right, they can start shipping earlier, right? So if they get to know that a particular printer is going to fail in the next 10 days or in the next 1 month or so because of a faulty part, either they can start shipping those parts ahead in time, so that as and when our printers stop working, they can immediately supply the part to us and then we can replace it. Or they can take proactive actions in terms of calling up the user and informing them that, okay, the printer is going to have certain issues, we would like to get that serviced for you and all that, right? So such use cases will specifically happen only for the corporates, but for individual homes, nobody is going to call you and tell that your printer is going to fail. But for all the specific corporates with whom the company has specific tie-ups, right, they will all have such liberty to have specific call support in place, right? So the data analysis is being done here. Again, once the data is being processed on the system, there is something called as a data warehouse. So on the Hadoop cluster, right, we will offload a lot of the analytical requirements here, but some of the analytical requirements, a subset of the information which is processed here goes back to a data warehouse again, and then we will perform visualization, and we'll create dashboards on top of that, so that the end users, like the end company owners, like the person, the CEOs or the managers of the company, right, they can take proactive decisions by looking at the dashboards. So if you see from a company perspective, right, all these bigger companies, they have whatever analytical platform that companies like TCS build, right? In the end, the actual consumers would be the top management of the company, right? They will directly, look at the dashboards before they probably come to the meeting. They have the liberty to view that in their mobile phones, in the tablet, as well as on the computer, right? So they while they travel to office, they will be able to get accurate insights about what is going on across the globe in a visualized representation. And then while they chair the meeting, they will be able to quickly make a decision on what needs to be done if they have to improve the overall customer experience and overall sales of the company, right? So that's the key advantages that a data processing engine, an AI-based data processing engine, would eventually provide to all the enterprises, right? Any questions?
So we would be displaying all the queries at the end of the session together.
Okay, thank you, no problem. So let's move on. The next one is about medical records. So this is another interesting use case where AI is being applied, right? So here, again, a US-based customer. This particular company has a lot of stake in many of the other companies in US and other regions across the globe. Okay, so all are kind of all the company along the parent company along with the subsidiaries, they are all into the healthcare industry. So they keep writing a lot of journals, write-ups. So the master company who is owning this system, right? They keep writing the scientist or the the core people in the company who has awarded the doctorate degrees and all on specific healthcare use cases, right? So they keep writing journals, and all those journals are getting published on their portal very, very frequently, right? And then all these subsidiary companies as well, right? They might be, let's say, the parent company, someone from the parent company, an authentic person from the parent company makes a write-up on a specific kind of molecular science or something, right? Or a specific kind of a medicine or a specific component which is available on a medicine, and then he is providing an end-to-end write-up, and then he is publishing on their website, which is 100% kind of authentic, a certified kind of information. But there are so many other companies or subsidiary companies, who will read that information and then try to keep adding certain information on their sites as well, right? So in US and all, this federal law is very crucial, right? So there are all this law, since it is being very stringent there, it is very important that the information which is maintained by these companies, right, the parent companies or the subsidiary companies, are highly authentic, right? There should be some kind of data validity that needs to be performed on the write-ups that are already in place. So let's say a person has written a 1,000-page document or a 100-page document, and if I am trying to read that information and then trying to write my own summary or inference of that information in, let's say, 1 or 2 pages, still whatever the primary author meant, right, that information should be there, even if I try to summarize it, right? So their requirement is basically to validate the information, right, which is written by the source, which is written by the primary source, against all the the extracted, against all the information which is written by the subsidiaries of the company, right? So there should be some kind of engine, an NLP based engine, which will predominantly go and run every day once, to see if there are any discrepancies in the information which is being written by the parent company as well as all the subsidiary companies. So in a way, they will be able to understand if there is something that is really misrepresented, then they can quickly take a decision to revert the particular the write-up which is uploaded, or basically to correct it and then upload it again, right? So there are different options. So all in all, the idea is to have a quality check being performed on the the text documents which are available on all the source systems, right? So some of the biggest challenges in terms of building such a system, right? If you see the systems, right, the data is being represented in different kind of formats, right? There are PDFs, there are Word documents, there are normal text. So there are certain images also, from which the information needs to be extracted. Right. So before even we validate the record, the primary target for us would be to extract all this information, which is residing in different kind of formats, to a single kind of platform. So we use different kind of technology. So one technology is Apache Tika, which can actually go and perform some kind of extraction on the data, right, on the images, on the text documents, and all that. Once the information is extracted using a document extraction engine, then we pass this on to the cloud platform, right? So in this case, again, the cloud is a preferred use case for this particular customer. So here the preferred cloud for this customer is AWS, which is Amazon's cloud, Amazon Web Service. So Amazon Web Service, Azure, Microsoft Azure, two major cloud partners that most of our customers have. Google is also fastly picking up. So these three cloud companies are going to remain, and there are huge requirements, right, in this area for companies like TCS in terms of building innovative solutions on the platform. So here in this case, on the AWS platform, we have something called as S3. S3 is nothing but a simple storage solution. Right, so it's a data store, right? It's a global data store, an object-based data store, which can accommodate huge number of data, right? It can, as and when you keep storing the data, right? It can accommodate data in petabyte scale and all that, right? So we use a document extraction to get all the document extracted, placed it into a storage medium like S3. And once the data is on S3, we use, there is something called as Amazon SageMaker, which is which gives a lot of, capabilities in terms of creating machine learning models, running the machine learning models on a preferred kind of a virtual machine or a system and all that. So we can use Amazon SageMaker's notebook capability to, build the code, deploy the code on the instance or on the server that we prefer to test and run and all that. And then the analysis that we are getting, right, can again be stored onto the Amazon Redshift, which is nothing but a data warehouse system, which is made available by Amazon for distributed data processing. So this is an efficient data processing engine. A lot of our customers are using it. So we use technologies like S3 for data store. We use technologies like Amazon SageMaker for building the machine learning models. We use technologies like Amazon Redshift to store the data in a raw column, or to represent the data in a raw column format, right? So one thing which we have to remember is, once we get all the information extracted from the source system, there is also a requirement to do a comparison between what is available on the internet, right? So that's where we have these kind of crawlers, right? Crawlers are nothing but, these are technologies that can actually crawl into any kind of internet, right? Any kind of websites that are being hosted in the internet. It can crawl through the net and then, extract or gather information which is being put here. So there are, technologies which are available in the open source community. There are custom built technologies as well. All in all, let's say if this particular, the document has to be validated against which is available on the internet, the company would have, let's say, 200 odd subsidiary companies. So we will be crawling only those 200 companies' websites, right? We will not go and crawl every site like how the Google is doing, right? Google is a, universal kind of crawler. It'll keep visiting every website to fetch certain information, right? But ours is focused very specific to the websites which the company is mandating. So we will go there, fetch all the relevant information, extract those, and then bring it here, right? So once we have the information from the actual source as well as from the internet, we perform a lot of analysis, data analysis on the data by keeping those on the cloud platform. The insights of that or the subsidiary information which is really required for data analysis would go to the Redshift. So there might be a lot of information which we can discard, right? So many of those informations are discarded. The relevant information goes to Redshift, and then again we build, dashboards. So there are technologies like Tableau, Power BI, and all that, which is which has huge demand in the industry right now. A lot of requirements on this area. So the biggest advantage of using such tools, visual tools for building data analysis, is that you don't have to worry about having skills on code, right? Building code, right? You don't have to have any kind of programming knowledge. People who knows the business logic can basically use such new age tools and then create dashboards there. Which will actually, get all the real insights which are required for the end users, right? So the actual analysis will get stored in Redshift, but it is in row and column format. By looking at the data, right, nobody will be able to, quickly take any kind of business decisions, right? So that's where it becomes a mandatory thing to represent the data in a visual form, right, in a graphical form. So if you take most of the AI use cases which are being done in the real world, right? Everywhere you will find a visualization layer like this, because that is the core thing that is required by all the senior management of the company, right? That can, help them to take better business decisions, right? By quickly looking at the graphs or the information which is available on the visualization layer. Also, as I said, if there are any kind of discrepancies which are there on the data, right, then there are certain alarms, right, that are generated in real time. So these alarms, if are basically categorized into different sets. So priority one kind of alarm is something that will find a major kind of discrepancy, right, in the write-up which is there on the source as well as on the target, right, when they do a comparison. So if there is a major kind of alarm or a major kind of discrepancy in the data set is being found, then those alarms, right, are quickly being transferred on to the key people who is supposed to take crucial business decisions, right? So priority one alarm goes as something that needs to be addressed immediately. Then there are 2 and 3 and 4 and 5 and all. So different sets of alarms are being generated by the system. The lowest priority, let's say the 5 and all, are something that can really be ignored. Right, but 1, 2, and 3 are something that needs to be quickly addressed, right? So that's what this whole use case is all about. Again, done for one of the leading medical device company based out of North America. Okay, the next one is sales forecast. This is a use case that was done for a pharmaceutical company based out of APAC region, Asia Pacific region. So their primary requirement, right? They are involved in creating a lot of medicines, right? Medicines can be like some medicines like the medicine which is required for fever treatment, cough, and all that. So they manufacture a lot of medicines. They have a major presence in Europe, US, and APAC, Asia Pacific. So they are one of the global leaders in creating medicines for the for different kinds of treatments, right? They have medicines for cancer treatments and all that. So any kind of TB and all that, right? They have medicines for that as well. So it's all kind of supplemental medicines. So the requirement for them, right? They want to increase the sales, right? Every medical company or every company for that matter want to increase the sales in one way or the other, right? So they have competitors. So every medical company would be thinking how they can improve sales of their medicine, right? How they can win over their competition, right? So these day-to-day task of increasing the sales is basically these days driven through AI, right? At at one point of time, it used to be driven through traditional approaches of, comparison of data, but these days it's all driven through the new age data analysis techniques and AI techniques and all that. So once they manufacture all those medicines, right, after going through all the traditional life cycle process that is involved, like the clinical trial and all that, before they ship the medicine onto the market, right, once it is on the market, then the sales information, right, the company would actually keep it on a files transfer server, right, like a secured FTP server. Okay, so let's say this is the company who is company by name ABC, who is transferring all their sales information for the previous months as well as for the historical months. So for the previous years, everything they are, let's say, they are maintaining on a file transfer, so a secured FTP server. And then there are companies like data providers, right? So data providers are companies which will sell the data which is available with them for a cost, right? So the company, let's say ABC, who is manufacturing a lot of medicines, wants to know how the competitor sales is, right? So these data providers will have that information with them. So the competitors' sales volume will also be available with the data providers. So companies like this, like the ABC companies, would actually pay some lump sum amount of money to the data providers, and they will get the competitor sales information. So this is something, on all these Fortune 500 companies, right? They will, do all this in order to perform, data analysis and then come up with the right kind of sales forecast and all that, right? So the whole thing is, the competitors' data is available for sales by these data providers. So these data providers, the competitors' information, let's say XYZ, as well as the company's ABC information comes onto the comes onto an SFTP server, and then once it is on the SFTP server, we will again try getting the data onto the data processing platform. Okay, so here again the data processing platform is Amazon Web Service. Amazon is this particular customer's preferred cloud medium as well. So again, S3 is the storage for managing all the data which is available. So both the customer's data as well as the competitor's data come and get placed on S3. Then we apply machine learning models and techniques on top of the data to find out how the how the current customer is sales is going on, how the competitor sales are being going on. Let's say the customer sales for a particular medicine, let's say a crossing tablet, right? For the past 1 year, if it is on a particular region, if the sales is on a lower side, and if the competitor sales is on a higher side, what they will try to do is they will try to come up with different kind of sales or marketing strategy, right? They might either go and meet the doctors in a particular region directly, and they will try to sell their products more, or they might try to give in a lot of freebies to doctors or hospitals so that their products are being recommended more than their competitors' products. So those are all internal business decisions that the end business managers make when they get the inference out of the data on the platform, right? So all in all, the sales report, right, from an implementation perspective, the challenge would be to, get all the sales report being generated in 2 to 3 hours, right? So timing is something which is very key in all the data analysis world. From a timing perspective, every 3 hours, if they want to know the competitors' information or the sales information, it's going to be a little tricky and challenging. But then that's how the system is, right? at one point of time when 6 years back or 7 years back, when all these data analysis techniques were just evolving, at that point of time, the end customer's expectation was to have some kind of dashboard, even if it is 1 month old, they were okay. They were ready to make any business decisions based on the data that is available after a month. But now the competition is becoming so intense that every company is looking forward to get the insights, the data and insights as soon as possible, right? So there is no correct timeline defined. It should be as soon as possible. Means if it can be generated in the next second or so, they are more than happy, kind of, right? So that's how the world is evolving. If they get insights out of the data as soon as possible, they would be able to make quick or better business decisions, right, as compared to their competitors, and they will be able to come up with their sales projections in a better way. So quick analysis of market and growth share for each of the customer products against the competitor products. Yeah, so that's what I covered. Then analyze internal performance and competitors' performance. So that's also something very important. So the company as such, right? They themselves as a company, can judge where they are. They can also at the same time judge how the competitors are growing, right? So they have different strategies to decide, right, if they think that they are falling behind the competition. Okay, so that's about this particular use case. So I'll move on. So next one is the telecom data analysis. This is also an interesting use case. This happened with one of the, again, Asia Pacific customer. So what they want to do, right? They want to analyze all the data usage, right? So they every mobile company, right, be it Airtel, Vodafone, or whatever companies, right, across the globe, every kind of websites that we visit, right, by using our phone, everything is recorded in their system, right? So if they get to know that, okay, we are spending a lot of time browsing Amazon for shopping, right? So they will have information about how much time a user visited a particular site. Let's say I'm using Amazon for 10 minutes. They will have the exact timing, right, with them. So they track each individual customer to the minute detail that without our knowledge, a lot of information are being automatically being taken by the system. So when we install any kind of app and all that on the phone, right, they ask us to accept certain things, right? So along with the acceptance criteria, they would have defined certain parameters, taking so and so information from our system, which we would without reading that, we would say accept, and then it automatically gets being captured. So the mobile the intention of this data analysis using the mobile data which is available, right? So they want to come up with targeted campaigns, right, like ad campaign and all that. So the profit of the mobile companies, right? So that profit will increase if they make us hook onto the phone for a longer duration of time, right? So the more we use the phone, the more profit for all the mobile companies, right? In terms of data usage and all that. So here there are two things. Okay, so one is the data which is coming from all the smartphones, the data which is coming from the tablets, and then there are data which is coming from the set-top box as well. Okay, so let's take the case of a set-top box, right? When we are watching a channel, let's say Asianet, we're watching a channel, right? And the moment we are watching a channel, start watching a channel, they'll get to know that, okay, they are the user is using watching Asianet at this point of time. The moment we try to switch over from one channel to the other, that information will also be recorded as an entry in the database on the backend system. So they will get to know, Asianet, the end companies who is selling the set-top box, right? They will get to know at what point of time the channel was changed and what made them change the channel. It could be a specific advertisement that had popped up at that point of time, which might have made the user switch the channel, right? So all those information are being captured. It might not be really captured to this level in India, but other well-developed countries are capturing all those information, right? So if you see Netflix and all, right, they capture all this information to the extent it is possible, right? So they create new episodes or serials of their own, right, by looking at the viewership. Right? If they get to know that, okay, in a particular region, a lot of people are watching a particular kind of program or a show, then they can create their own show similar to that, and then they can sell it. So that's the whole idea, right? So this particular company, in the end, it is capturing all the information which is available from the phones, from all the electronic devices, right? From the the smartphones, from the tablets, and from the set-top boxes and all which they have deployed. Okay, so from all these systems, logs are being extracted. So how they get all this information? Because every time when we make a movement, everything is written to a log within the system, and then all these log files are being captured onto a Hadoop cluster, which is a big data processing cluster. And then it goes through multiple clusters and comes onto a data warehouse system. And once the data is available on the data warehouse, right, we can have data visualization, predictive analytics, and all that being run on the data which is available there. So in the end, if we are browsing through an Amazon website, and if we are specifically looking for a particular product, then they will try to sell that product by probably through a competitor by giving it for a lesser rate or something. So that's the whole idea. In the end, the plan of these bigger telecom companies is to make us use this system, the handheld devices, as far as possible, so that they can get revenue out of it, more and more revenue out of it, right? Okay, so I'll move on to the next. This is about shipment. Again, this is for a North American customer. It's basically a cargo company. How they can improve the overall shipment experience, right? So that is what they want to understand. Okay, so let's say I am shipping something from Kochi to New York, right? If I'm sending it today, right, on 1st of December, then it should reach on so and so date, like within the next 10 days or so, right? So how the shipping company can ensure that over a period of time, right, when we keep sending information, keep sending all these parcels, right, how do they ensure that it reaches them with the on the right time, with with zero damage or something, right? So they have lot of internal systems in which all these informations are captured. So they have their own supply chain management system, which will keep track of all the shipment activities, be it shipment through airplanes, be it through the ship, or be it through any kind of trucks and all that, right, which will actually carry all the information. So everything is being captured here on the supply chain management system. And based on the historical information which is available, right, a shipment process which is done, let's say last year or last to last year. So we will in order to have some kind of a prediction model, right, we need some level of historical information as well, right? So all those historical information for, like, let's say last 10 years or 20 years or so, everything would be available on this supply chain management system. So again, as and when the data volume increases, right, in the end, we cannot have a single kind of machine to process the whole set of data. We need a distributed platform like a Hadoop cluster, which can actually get all the information and process in a distributed way. So Cloudera is one of the Hadoop distribution that we are using. It's a on-premise Hadoop distribution. So when I say on-premise Hadoop distribution, so there are two different kind of platforms which are available in these days, right? One, I can have my own systems in my office or my premise, and then I can process the data there. Or I can use any cloud platform, get onto the cloud and process it there. So these days companies are, moving towards cloud, but there are certain companies that have those companies who have already made huge investments in their on-premise systems, and also companies like some of the medical companies I've seen, they are very speculative about transferring the data onto cloud, especially the sensitive kind of information that they have. So they categorize their data into two, the sensitive information as well as the non-sensitive kind of information. They call it as GXP as well as non-GXP. So that's a terminology that is predominantly used in the enterprise world, right? So what that means is, all the sensitive information, they will try to maintain it within their network. All the non-sensitive information, they try to maintain it outside the network, like on a cloud platform. So in this case, everything is on-premise because they already have made huge investment on a distributed platform. So they want to continue using that. So all in all, the idea is to get all the information from the supply chain management system onto the platform. So there are many systems which are actually capturing this information, right? There are SAP systems, there are systems like JD Edwards, there are data residing in RDBMS systems like Oracle. So though I represent everything in a simplified way, there are a lot of logics and computations involved in the back end, right, to get all these information. Because when I ship one product from one location to another, a lot of information on the way it is captured, like what is the next hub, and then whether once the equipment reached a particular location, whether they have done a scan operation on the equipment, so from when a particular product or goods move from one location to another, internally a lot of things happen. All those informations are eventually captured in multiple source systems. It can be SAP systems, it can be RDBMS systems like Oracle. In the end, our whole idea is to extract all the information from in real time. It need not be real time. It can be a batch kind of system, where in which we try to extract the information during a time frame where the system is less frequently used onto the platform. Then we apply different, if there is a requirement to have some kind of predictive analytics, right? Then a specific kind of machine learning model would be created to build that. The intention is, once we build a model, right, based on the past, based on the past data, it should be able to predict how the shipment is going to be arriving, right? Are there any delay that is supposed to come? So if there are going to be delays in the shipment, then we have to proactively analyze that and inform the end user, right, who is expecting the shipment, that okay, there is a delay in your shipment. And also there are so many other parameters that are evaluated in terms of having the quality of the shipment process being established and all that. Okay. Next is again an NLP based use case for a telecom customer. So this is about trying to reduce the number of complaints, right, that are being created by the end users like us, right? Let's say, I being an Airtel customer, if I file a complaint, right, because of so and so reason, there may be so many people, right, from different regions of India would be registering a lot of complaints with respect to the quality of the with respect to our voice quality, or with respect to the range that we have and all that. So this customer, again, not an Indian customer, but a Singapore-based customer, their primary aim is to reduce the number of complaints as far as possible, right? So if the number of complaints are on a higher side, how they can reduce it to the lower side, probably make it zero, right, by doing all these data analysis, right? So the complaint can come either by user typing on the portal, or it can be through their call center, where in which the person is directly calling their call center and complaining about complaining about the services of the particular mobile company. And then there are chatbot applications as well, right? These days there are a lot of chatbot applications. So for this particular customer, the chatbot is nothing but if you visit Singapore and all, right, this customer there, in some of the offices, you will not find any kind of sales representatives, right? I have visited one of the office where in which I couldn't find even a single salesperson. All we have are like chairs, and then there will be a kind of a chatbot application, a screen that would be there in front of you. We will be talking to the chatbot application, and that application would take care of all our needs, right, in terms of addressing our complaints, in terms of giving a new connection, and all that, right? So the entire set of 30 odd humans, they have completely replaced it with the chatbots. So for them, the information which is coming from very crucial. So everything gets extracted using a data extraction engine onto a big data management platform. So there is some technology called Informatica. Informatica Big Data Management is a tool which can, rather than using code to build any kind of data analysis, these are UIs, right? It's kind of a drag and drop interface, where in which you can drag and drop different components, analytical components, and perform data analysis in a faster way, and then feed it back onto the output of those analysis. If it has to be represented in a row and column format, right, it will go on to the enterprise data warehouse. The data warehouse again resides on the customer network. So on the data which is coming from all the systems, right, we apply a lot of NLP techniques. So we do a lot of pre-processing on the data, trying to cleanse the data, removing all the unwanted information which is required for data analysis, or removing all the columns, all the spaces, unwanted spaces, commas, and all that, and convert that into some kind of a numeric form, right, before we pass it on to the NLP system. And the inference of that goes back to the data warehouse. At the same time, it goes back to the end the visualization layer, where the business users, right, who are actually monitoring the system, they can see on a particular region if the complaint is on a higher end, or overall globally if the complaint is registered by customers are going down or not, right? So in that in the end, their vision is to make more happy customers, rather than creating a lot of customers with dissatisfaction elements among them, right? So so reduce calls to customer care by deriving additional insights, right? So the number of calls to the customer care center, the number of escalations, the negative feedbacks that are being provided by the customers, all should eventually get reduced. And then overall improve the customer experience, right? So that's how they can keep on adding new and newer customers. So one example is, let's say from a Kochi, from one specific location, if the if lot of complaints are coming in terms of having an issue with the mobile range, right? They can quickly take a decision to add additional towers in that location to address the additional customer needs, right? So such activities can be done by looking at the data which is available after analyzing all the data which is available from the source systems. So this is something which the developed countries are very good at doing. Our country is still evolving in this phase, but these days a lot of customer complaints are getting reduced. But overall, if you see, many of these companies apply a lot of AI techniques to get to this level, right? Excuse me. I think this is the second last one that I have. It's about alarm management. So again, this is for a mobile company. So if you see right on the left side, we have all these towers, right? So on the towers, there are a lot of hardware devices. A lot of information gets extracted from these hardware devices. It's called a SNMP protocol, right? So SNMP protocol, Simple Network Management Protocol. That's a protocol which gets attached very closely to the hardware devices, which can extract a lot of information, and then by decoding those information, right, we will get a lot of inference from the data in real time. So the SNMP, the SNMP tie-up information which we are getting from the system, it needs to be converted to a format which the programming language can understand, right? So there are different techniques that are available in the market to get those information. There are different, we call it as API, application programming interface. API is available to decode the information which is coming up from the end hardware devices. So if there are any fault in these towers, right, in the end, as an end user, we will not be enough range for making a call, right? So their idea is many of the hardware devices which are deployed there, once it generates any kind of alarm, right? There should be there are systems which are already in place to to take an action when an alarm is generated, right? As and when an alarm is generated, what the traditional system does is it will try to take proactive actions by either replacing the device or by rectifying the problem which is there on the device, right? So there are systems which is in place in the current world, but there are the systems which can actually predict if there is a failure that is going to occur, right? So such systems are still evolving. So that's where the AI comes into the picture, with a lot of predictive maintenance capabilities being embedded into these kind of systems, right? If I know that a particular component within a tower or a telecom device is going to fail in the next 10 days or so, I need not wait till the failure occurred, right? I can quickly take proactive decisions based on the data which is already available. So that's where the analytical environment based on MapR. So MapR is again a distributed Hadoop platform. These days it is less frequently used. So this was some use case which we built I think 2 years back for one of the customer. These days a lot of cloud technologies are being given more focus than the analytical environments like MapR and all that. So all in all, be it on cloud or it on-premise systems, the whole idea is to analyze the faults well in advance using using algorithms which are available on the AI libraries, right? So one thing which you have to remember is Python, right, which is very well used. There are a lot of machine learning models that are available in TensorFlow, Keras, and all that, which are very well used by companies like TCS. And also there are Spark mlib, right? Spark has a specific machine learning library which has specific set of machine learning pre-built models that are available for data processing. And along with that, Azure has their own Azure machine learning services, and AWS has AWS machine learning library, and Google has Google's own machine learning libraries that are available, right? So in the end, nobody is going to build any kind of machine learning models from the scratch. Instead, we are all the companies these days, they are going to use a kind of a transfer learning model, wherein which will use some of the existing models knowledge or capabilities that is available, and then we will try to reuse those knowledge already in place with additional insights of our own, right, which we are providing to the system. So that's where from an implementation perspective, everything happens. So in the end, for data consumers, right, who are going to monitor all these logs and all in real time, all these alarms in real time, they will be having a query interface, an analytical set of analytical tools available for them to perform specific set of queries that are coming in from the system. They also have visualization tools to graphically find out if this a particular system is going down, or how many systems were faulty over a period of time. So if they let's say a company like Airtel has procured a tower from a vendor like Ericsson, right? They are one of the leaders in manufacturing telecom equipments, right? So if they get to know that one batch of telecom equipments which a company like Ericsson has shipped use, then they will be able to quickly analyze all that and find out, right, if a particular batch of device are faulty or not, right? So then they can go and discuss it back with the vendor who has shipped those equipments, and then they can either take proactive decisions to correct all their products, all their ongoing products which are in pipeline, or they can have certain kind of proactive measures taken to rectify the current workloads. Okay, so this is the last one I have. Again, one interesting use case. It's about streaming data analysis. So one of the European customer which we have, they have deployed a lot of cranes, right? Cranes and nothing but those ones which actually pick a lot of loads, right, from, and then move it from one location to the other, right? So as and when a shipment happens, right, these high powered cranes, right, they can actually lift all those heavy items and then pick it up and keep it on the ship in an order, right? So that a lot of manual interventions are avoided. So the whole idea is it's not just one crane that does everything. There are thousands or even lakhs of cranes that are manufactured by these companies and deployed it globally in different shipping units, right? So this one specifically for the Europe region, all those cranes which are manufactured and shipped, there are a lot of sensors being deployed in the devices. So it's not just one sensor. There are a number of sensors being deployed in the engine to track the engine's performance when it makes a movement, right? When it makes a left or right movement, to capture the movement, there are sensors being deployed there. So all in all, the idea is to find out if there are any faults that can occur in the cranes when they are performing all these heavy lift operations, right? Because the probability of wear and tear is more here as compared to a normal equipment, right? Because it does a lot of heavy lifting. At any point of time, it can fail. And if, let's say, a crane fails to pull a particular, a quantity of package and then lift it onto the ship, then they have to think about procuring new set of cranes, and there is a delay, right? So every shipment has to be delivered on time. If there is a delay, then that means there is cascading delay everywhere, right? So think about a scenario where a ship has to start from Kochi to, let's say, Dubai. It has to start now in the morning and it has to reach in the next 5 days or so. If it gets delayed by 2-3 days, then there are there is a weather forecast coming after 5 days, that there is a kind of a cyclone or a storm which is going to come in a specific region on the travel path, right? So if that happens, if so, all these cranes which are actually doing a lot of heavy lifting, if that becomes a failure, then there will be delay in shipment, and that would again further delay, because they will have to again wait till this natural calamities like this is over before they can start shipping again, right? So time is very crucial. So in this digital world, right, if we have to follow the accurate timing, then a lot of data analysis or predictive analysis needs to be done in advance on the data, right? So the information which is available on all these sensors are captured in real time through a messaging queue uh, to a data acquisition platform. So this platform, which is built by our company, is capable of fetching all those information from all these systems in real time, and then it passes on to a distributed data platform, a data processing engine for data analysis, right? So along with the data which is coming in real time, so there is also a requirement to basically analyze the organizational wide data which is available on systems like SAP systems. Because it's not just about analyzing the current data, it's also about analyzing the historical information which is available there, right? Because these systems like SAP systems will have the actual detail or entry about the kind of shipment that we are making, right? Whether we are packaging, whether we are shipping 10 different items or 100 different items, to which location are we shipping, when are we supposed to deliver, what is the committed date, who is the end consumer who is looking for this particular shipment, how much shipment he has already made, is he a long-term customer or is he a new customer? So all those things are very important, right? Because customers who are there with these companies for a longer time, for them they want to get more attention than probably a new customer, right? So it's all up to the companies to decide what needs to be done. So in the end, the data which is coming from the sensors as well as the data which is available on the organizational system, everything has to come onto a distributed data processing platform for data analysis, right? So we apply different data analysis techniques on this platform to have a lot of inference from the data. So one of the crucial element, right, when this machine is making a movement, right, let's say it is making a left movement and it is making a right movement, the amount of torque or the force which the system has to apply, it should be kind of uniform, okay? So if we get to know that, okay, more than the normal pattern, normal uniform motion, if it is trying to generate too much of motion, then we can consider that as an anomaly of the system. So that is the kind of inference we are trying to get by looking at the time series kind of data which is coming in real time from all these systems, right? So the sensors which are embedded in different parts of the equipment will forward a lot of information. The information can be with respect to the movement of the machines as well as the engine capacity, right? Let's say the engine is generating a similar kind of pattern when it works fine, but there is an unusual pattern that the engine is generating, which we will not be able to understand, but the sensors which are built in there will be able to capture all those information. And if we find an unusual pattern, when we know that, okay, the engine is going to fail in the next few days. So what these companies, these crane manufacturers will do ahead, right? So they will try to procure more and more cranes, and then they will try to replace the faultier ones with new cranes, so that the process of the movement of shipment from one location to another is never hampered in terms of failures, like the crane failures, or this one, right? The arm of that one should also make accurate movements. It cannot fail at that particular location as well, right? So there are many crucial elements in this whole mission which needs to be monitored in real time, and accurate business decisions has to be made. So that's where the AI is very much in place, right? So typically the new trend that whatever we are seeing, a lot of push for building every system with an AI flavor. That push is coming from both our customers as well as from their business, the business as well, right? And at the same time, a lot of focus to have all these analysis quickly in place, and that's where cloud is coming into picture. If we have to, let's say, create some kind of analytical platform like this on an on-premise within our office, right, then it would take a lot of time to come up with the code on how much the cost is going to be. Then we will have to get an approval from the management to get those costs sanctioned, and at the same time procuring the hardware, the kind of specific hardware that we might be looking for might not be available at that point of time. Let's say you get that, then again, how the amount of software that needs to be added onto the system, and then we need people to maintain all those systems. So in the end, to build a platform of our own might take 2-3 months, but if the requirement is to have the data analysis platform in place quickly, that's where the cloud is coming into picture, right? So the kind of push that we are seeing towards cloud from most of our customers, right? So that's huge. So from an organization perspective, we have a lot of requirement in terms of AI skill set, in terms of cloud skill set, in terms of applying the knowledge to apply a lot of machine learning models or techniques, also at the same time to apply data analysis and create some kind of visualization on the data, right, using tools like Tableau, Power BI, and all that. It's so important for us. So there I end my presentation. I think we can, the next 5 minutes or so, if there are any questions, I can address that.
Sure, sir. We'll be displaying those queries now on screen.
Sure.
Sir, could you please stop sharing your screen?
Just a minute. Yeah, I've stopped.
Yes, sir. We would be displaying those queries now.
If we implement AI in medical practices, how can we make sure that nothing goes wrong while performing surgeries, etc., without any complications? How do they recognize the region where they have to perform these operations, as different people have different system? I meant their body composition, etc. It is not the same for everyone, right? Yeah. So when I say an AI procured or AI based medical device system, right? So this is the use case that we have is a specific customer, right? So if that customer has to analyze the data, all the hospitals with which they have tie up, right? Everybody should use the same kind of machine. So if different hospitals are using different kind of systems, we will not be able to have a single platform for data analysis, right? So that's where we need to have a common system in place by this particular specific customer, right? So there are robotics devices which are manufactured by different medical devices companies, but if if a lot of hospitals are going to use, in US they're already using, right? In US they're already using the medical devices which are supplied by this particular company themselves. So for them it is easy to perform analysis on the data. At the same time, their systems are very well developed, right? So I have, when I visited one of their US site where they are manufacturing a lot of these medical devices, right? So I've seen, in order to test the quality of the devices, what they are doing is they have created or replicated in a body of a different set of humans, right? So let's say they are performing a surgery on a specific tummy, right, on a stomach surgery on a specific patients. The stomach can vary from the size of the stomach can vary from different person to person, right? So they have replica of different kind of human body available, right? And then they keep on testing on these devices on different set of kind of human replica, and then once they are 100% sure that it works fine, that's when they take these to the hospitals. And during the initial part of all initial surgical time, right, there will be doctors who will be assisting. It will not be on one fine day, all the robots will not take over humans just like that, right? So there are doctors who will be assisting these surgical procedures in the beginning. So once everything is in place and once the system is fully functional, that's the only that's the time when the robots are completely going to take away the human surgical process. Okay, so the next one is, what is the difference between data warehouse and operational database, right? So data warehouse, so when we yeah, okay, I think Adrian Verghese asked that question. Okay, thank you. So data warehouse, right? Data warehouse is nothing but a platform used for especially for analysis purpose, right? The operational database are nothing but the databases. So if we have to capture all the information, right, let's say when we performing a railway ticketing reservation, right, the information has to be captured now and then, right, because the read and the write speed of the system is very important. So that's where all these RDBMS or the operational database systems, which will actually take all the information and store it in real time. So systems like the railway reservations or the ticketing systems or any kind of systems which will actually expect data to be stored immediately, and the system should also be able to make any modifications to the data, right, now and then, perform any kind of updates on the data. So all those are operational systems. But there are systems which are analytical based systems. So those are data warehouse systems, right? So on the operational database RDBMS systems, we will not be able to fire any kind of complex queries, SQL queries, and get the insight, right? So that's going to be a challenge, okay? Because if the volume of the operational data warehouse is going to increase beyond a scale, then you'll not be able to have complex joins between different tables and create a analytical querying system on top of that. So for all the analytical requirement to perform data analysis, we have enterprise data warehouse. So what they do is, over a period of time, right? Let's say the operational database systems are less frequently used. Let's say our railway ticketing system, after 12 o'clock, if the system is being used less frequently, then in between 12 and 2, or let's say 1 and 2 or 1 and 3, the data which is there on the operational database system can be transferred frequently to the data warehouse system. So the data gets offloaded along with all their historical information, gets offloaded to the data warehouse system. And on top of the data warehouse system, these data warehouse systems are specifically designed to run complex analytical queries, right? Because to get the data inside, we might have to join multiple different tables or multiple different databases, which are nothing called cross-join databases, and get the queries. So, both the operational database systems, both the data warehouse systems, both are going to remain, right? Both will work hand in hand. One is specifically used for all your day-to-day operations. One is specifically used for all your analytical needs. Okay. Can SNMP be associated with the AI only for network abnormality detection? So SNMP is it's a simple network management protocol. It is not just associated with AI, right? So in the traditional world, the SNMP is there. I know the SNMP systems are available for the past 20 years, right? So those are specifically to detect faults which are available on the telecom networks, right? So it's a set of software which resides very close to the hardware, right? So it can emit the data in the form of ones and zeros. So earlier there were no capabilities, AI capabilities embedded onto the SNMP systems. So it was about reading the information which is available on the hardware devices. Using that information, they used to build their traditional systems in order to generate alarms and all that if a system used to fail. But now the systems, the legacy systems used to get the information only when a fault used to happen, right? But all these new age AI technologies, when that is in place, we don't have to wait till a system becomes faulty, right? We can actually look at the data and come up with a predictive model, right? If we know that in advance that okay, telecom tower is going to fail in a month or so, then that's a better thing for the business, right? They can actually start rectifying the system in advance. So it is not just for from network abnormality detection perspective. Anything which is available on the data, right, can be analyzed from the SNMP systems. Okay, anything else?
Thank you, sir. Participants, do we have any more questions coming up? If there are any more questions, you can unmute yourself and ask. Sir, I think we don't have any more questions. So
Okay.
We can wind up the session.
Okay. Okay. Thank you so much for
Thank you.
joining.
Yes, sir. Thank you so much, Jeetu sir, for the highly inspiring time with us. Your remarkable depth of understanding of the subject has made the session an exceptionally stimulating and informative one. On behalf of the entire faculty and staff of the Department of Electronics at TIST, I once again express my gratitude for your presence that has definitely enriched the session. Thank you so much, sir.
Yeah. Thank you so much. Thank you. Have a good day. Bye.
Dear participants, we'll wind up with the session now, and the next session will begin at 3 p.m. Attendance link has been posted in the chat box. We once again remind you that certificates would be provided only to those participants who attain an attendance percentage of 80 and who score a mark of more than 60% for the online test that would be conducted at the end of the STTP. Thank you all, and we'll resume the session at 3 p.m.